Hello, Science Fam. Today we are looking into not only balancing equations, but being able to identify what type of reaction it is. Remember, we've learned about single, double replacement, synthesis, decomposition, and combustion. So let's take a look at how to balance them, but also what type of reaction they are. So I'm going to look at, first of all, for number one, it looks like I have a compound here and a compound here. So AX and BY, it looks like. And if you look, it looks like the sodium and aluminum swap. So now it looks like AY and BX. So what type of reaction has that outline where both swap? That's going to be your double replacement. So I'm going to put a DR for that. So let's balance this out though. If we start, we have 3 chlorines over here. So on the product side, I'm going to put a 3 for 3 chlorines. Now remember that 3 also goes to the sodium, which I already have 3 of. So that's great. So it looks like my sodiums and chlorines are balanced. On the product side, I have 1 aluminum. Reactant side, 1 aluminum. On the reactant side, 1 group of PO4, that's called phosphate, and 1. So it looks like I am going to balance this as a 1, 1, 1, 3. Perfect. Let's look at this next one. If I take a look at number 2, I have a compound like AB, and then it breaks apart into 2 different pieces, A plus B. If we think about what type of reaction that is, that's definitely going to be a decomposition. It's decomposing. So for short, I'll put decomp. But that is definitely breaking down into pieces. All right, so let's balance that out. We've got, let's see, 1 carbon over here, 1 carbon over here. 4 chlorines on the reactant side, only 2. So it looks like I just have to put a 2 there. And that's going to balance out. 1, 1, 2. Looking at question number 3, it looks like I have something all alone, lithium, and then I have a compound, so I'll call that BX. Then it looks like, look at barium, got kicked out, it's now by itself, so B's here, and now I have AX. So what is that? 1 lone replaced, so that is a single replacement reaction, so I'm going to call that SR. So to balance it, let's take a look. Looks like there's 2 chlorines on the reactant side and only 1 on the product. So I'm going to need to put a 2 there. Now my chlorines are balanced, but that also now is going to affect my lithium. There's 2 over there, so now I need 2 on the reactant side. 1 barium on each side. So it looks like this is a 2, 1, 1, 2 to balance out. If I take a look at the next question, number 4. It looks like I've got a hydrocarbon, right? It's carbon and hydrogens, and it could be any amount of carbon and hydrogens. But whenever it reacts with oxygen, the 2 things it always gives us is water and CO2. So we would call that definitely a combustion reaction. I'll just put combust for short. In order to balance this, remember that there's oxygen in 2 spots. So these ones can be a little tougher to balance. So I'm going to leave oxygen for last. So whenever I do combustion reactions, I always balance carbon, hydrogen, then oxygen. So let's do that. I've got 8 carbons over here. So I'm going to do 8 times 1 carbon over there. Now remember, that 8 is going to multiply by the 2 oxygens. So I'm going to have 16 oxygens, but I'm not going to do anything with that because I have to worry about the other oxygen too on the product side. Let me next do the hydrogens. There's 18 hydrogens. 9 times 2 will give me 18 hydrogens. But remember, that's 9 times 1 oxygen. So now I have 9 and 16 oxygens on the product side. Well, 9 plus 16 is 25. So if I have 2 oxygen, what times 2 will give me 25 to balance out with the product side? Well, that is 12 and a half. 12.5 times 2 gives you 25. So now this equation is balanced, but as we know, unfortunately, we can't leave 12 and a half as an answer. So if you guys remember the trick, I need to get 12 and a half to be a whole number, and I can't round it, so I'm going to have to double everything. So 1 becomes 2, 12 and a half becomes 25, 9 becomes 18, and 8 becomes 16. Now I'm still balanced with the same ratios, but now all of the coefficients, the big numbers, are whole numbers. Much better. Taking a look at number 5, I've got a compound, and if you look, barium and ammonia, sorry about that, barium and ammonium are going to swap. So what do you call that when you have two compounds and they're swapping? That's going to be a double replacement reaction. So let's start balancing this. If you take a look, this is a polyatomic ion, chromate. That's a couple things, but that sticks together. Also nitrate, NO3, stays together. So we're going to treat those big chunks. Oh, and there's ammonium too. We're going to treat those big chunks as one piece, and I think that'll help us balance things out a little bit better. So if you look, ammonium, NH4, there's two of them. So I'm going to put a 2 here to give me not only 2 ammonium, but also 2 NO3s, which are nitrates. But now that I have that, 2 nitrates, NO3, I also have 2 on the reactant side. I've got 1 barium on each side, 1 chromate on each side, and I end up balancing it out. So at first, this might be an intimidating one to balance, but really when you look at it and you chunk everything together, it just became a 1, 1, 1, 2 to balance. Let's move on to number 6. You have 2 separate things on the reactant side, and notice after the arrow, there's only 1 product. We call that a synthesis reaction when you start with pieces and it becomes 1. To balance this, let's take a look. There's 2 oxygen and 3 oxygen. Oh, well, those are not equal, so the nearest number 2 and 3 can both be with multiplication is 6. So I'm going to need to do 3 times the 2 oxygen to give me 6. And I'm going to need to put a 2 in front of here to give me 2 times 3 to give me 6 oxygen. But because that 2's there, it also multiplies that nitrogen. There was 2 already, so 2 times 2 is 4 nitrogen. So I'm going to need to put my 2 times 2 there to give me 4 nitrogen. But now I'm balanced, which is great. If I take a look at number 7, I have an individual element trying to jump in to a compound. And what happens? Now the cation is by itself, and aluminum is now with the compound. We call that a single replacement reaction because you have 1 solo element trying to come into an actual compound. So to balance this, take note that NO3 nitrate is still all chunked together. There's 3 nitrates on the product side and only 2 on the reactant side. Well, 2 and 3 we know aren't equal to each other, and the nearest number they both can equal to each other with multiplication is 6. So I'm going to need to put a 3 and a 2 in order to get 6 nitrates. But we know because of that, that's going to affect other elements. So 3 zincs there, so I'm going to put a 3 there. 2 aluminums there, so I'm going to put a 2 there. Now that I have that, I think I'm all set and balanced, and we are good to go with a 2-3, 3-2 balanced equation. If we look at the next question, number 8, I have 2 compounds. If you take a look, the cations switched. So to me, that is a double replacement reaction. Now that I have that, I can start worrying about balancing this out. Again, if you take a look, there's OH, that's a hydroxide ion. OH is over here too, so I'm chunking those. CO3 is carbonate, and it's over there too. So the nice thing, even though this is a lot of letters, we can treat them as one whole thing. So let's take a look at if anything is not balanced. And it looks like the hydroxide, there's 2 here and only 1 over here. So I'm going to put a 2 here. That's going to give me 2 hydroxide, but also 2 potassium, which I have right here. In the end, I'm having a feeling, I'm going to double check, but I think that's actually going to be balanced with just that 2 there. So sorry, I'm cleaning up with my eraser here. Well, let's take a look. 1 calcium, 1 calcium, 2 hydroxides, 2 hydroxides, 2 potassium, 2 potassium, 1 carbonate, 1 carbonate. Perfect. Then that just becomes a 1, 1, 2, 1. Balanced out. Number 9, you're starting with 1 compound on the reactant side, and it's breaking down into pieces. We call that then decomposition because it's decomposing, it's breaking down. or decomp for short. Now, let's balance this out. And it looks like 1 carbon, 1 oxygen, 1 carbon, 1 oxygen. Nice. This is already balanced out. That was nice and straightforward. We like that. Let's jump to the next one then, since we're on a roll here. Number 10, you have aluminum all by itself. And then all of a sudden you have silver by itself. So it looks like aluminum kicked silver out. We know when you have a loner that's trying to kick another one out of a compound, we call that a single replacement reaction, or SR for short. So now all that's left to do is balance this out. If you take a look, nitrate, NO3, there's 3 of them. There's only 1 nitrate here, so that means I'm going to need a 3 to distribute to that nitrate. But because of that, it's also going to distribute to my silver, Ag. So I'm going to need to put a 3 there. In the end, I balanced it with a 1, 3, 3, 1. Let me clean that up for you so it's not too sloppy. There we go. And we're balanced. Perfect. Moving on to number 11, compound and compound, and it looks like the cation switched. That to me looks like a double replacement reaction. So now that we know that, we can balance this out. Let's get to it. All right. Well, hydroxide stays together, OH, okay. There's 2 and 3, so we know the deal. When those aren't equal, 2 and 3, the nearest number is 6. So I'm going to put a 3 here and a 2 here, and now my hydroxides are at least balanced. However, because I put those there, it also made 3 calcium, so I'm going to need a 3 there. And let's see, that then makes 6 bromine, ooh, and I have 3 over here, so I'm going to need a 2 here. Ooh, and then that made 2 aluminum, but I think I already had 2 aluminum. So perfect. I'm pretty sure I'm balanced. So I'm going to clean this up, and let's just go through everything really quick to make sure I have the same amounts. So I've got 2 aluminum, 2 aluminum. 2 times 3 is 6 bromine. 3 times 2 is 6 bromine. I've got 3 calcium, and 3 times 2 hydroxide is 6. 2 times 3 hydroxide is 6. So 2, 3, 2, 3, all balanced out. We are on a roll. Let's keep going with the last one. Oh, here we go again. We've got that hydrocarbon, right? And it's reacting with oxygen and always making water and carbon dioxide. There's only one type of reaction we know that does that. That's called a combustion reaction. Now that we have that, let's have some fun balancing this one out. As always, like I say, because you have oxygen in 2 different spots, leave oxygen for last. So balance carbon, hydrogen, and then oxygen. So let's do that. Carbon's first, 5 carbon over here. I'll drop a 5 here. Now remember that 5 times 2 oxygen gives me 10 oxygen. But I'm not going to do anything with that oxygen yet. Just relax, okay? Next up, let's do the hydrogens. There's 10 hydrogens. So 5 times 2 will give me 10 hydrogens. But remember, that 5 goes to that oxygen. 5 times 1 is 5. 5 plus 10 is 15, so you have a total of 15 oxygens. You only have 2 on this side, so you're going to have to do 7.5 times 2 will give you 15. You drop a 1 there, and now everything is balanced. But as we know, we can't just leave it at that, unfortunately. Even though it is balanced, it's not balanced with whole numbers. There's no such thing as a half an oxygen molecule. So if you remember, the strategy is just to double everything so that 7.5 becomes a whole number. So 1 doubled becomes 2. 7.5 doubled becomes 15. 5 becomes 10 doubled, and 5 becomes 10 doubled. Now we should have everything equaled out, and we're balanced too. So we're good. Right, nice job, science fam. We are practicing not only balancing what you're expected to be confident with now, but if you're not, this is a great time to get some extra help. So don't be shy in coming in, getting extra tutor help, whatever it is. And then also, you need to be able to identify the 5 types of reactions we have covered. And just to recap on that, remember the 5 reactions we've covered are single replacement, double replacement, synthesis, decomposition, and combustion. Well done, Fens. Have a good one. Be well.